equation, we have to evaluate the definite integral x tan x divided by sec x plus tan x into dx from 0 to pi. Let's begin with the solution. And let I be the integral x tan x divided by sec x plus tan x into dx from 0 to pi. Now, by using the property that integral of fx into dx from 0 to a can be written as integral of f of a minus x into dx from 0 to a, the given integral I can be written as integral from 0 to pi minus x of tan pi minus x divided by sec of pi minus x plus tan of pi minus x into dx. Let us denote this equation by 1 and this equation by 2. This implies that I is equal to integral of pi minus x, and tan pi minus x is minus tan x. So taking minus sign here, we have tan x divided by sec of pi minus x is minus sec x plus tan of pi minus x is minus tan x. So taking minus sign common, we have sec x plus tan x into dx, and the integral is from 0 to pi. So on cancelling the negative sign, this implies that I is equal to integral from 0 to pi minus x into tan x divided by sec x plus tan x into dx. Let us note this equation by 3. Now adding equation 1 and 3. On the left hand side we get I plus I, and on the right hand side of the first equation we have 0 to pi x tan x divided by sec x plus tan x into dx, plus the right hand side of equation number 3 is integral from 0 to pi minus x into tan x divided by sec x plus tan x into dx. So this is further equal to, on the right hand side we have integral from 0 to pi x tan x plus pi tan x minus x tan x divided by sec x plus tan x into dx, and on the left hand side we get 2i. So this further implies that I is equal to 1 upon 2, taking pi common, we have integral 0 to pi tan x divided by sec x plus tan x into dx. This further implies that I is equal to half pi integral from 0 to pi. Tan x can be written as sin x divided by cos x whole divided by, here sec x is 1 divided by cos x and tan x is sin x divided by cos x. So taking cos x common, we have 1 plus sin x divided by cos x into dx. So this further implies that I is equal to pi upon 2 integral sin x divided by 1 plus sin x into dx from 0 to pi. So this is further equal to pi upon 2 integral from 0 to pi, in the numerator adding and subtracting 1, divided by 1 plus sin x into dx. This can further be written as pi by 2 integral 1 into dx from 0 to pi minus of integral dx divided by 1 plus sin x from 0 to pi This is equal to pi by 2. Integral of 1 with respect to x is x, and this is from 0 to pi, minus integral dx divided by 1 plus sin x. Now multiplying the numerator and denominator by 1 minus sin x. Here we are rationalizing this function, and the integral is from 0 to pi. So this is equal to pi by 2. On solving this, we get pi minus 0, that is pi, minus 0 to pi 1 minus sin x divided by 1 minus sin square x, that is cos square x, into dx. Now this is equal to pi square divided by 2 minus pi by 2. Integral of 1 divided by cos square x is sec square x into dx from 0 to pi. And we have minus integral of sin x divided by cos square x, that can be written as sin x divided by cos x into 1 upon cos x, and sin x divided by cos x is tan x, and 1 divided by cos x is sec x. Then we have into dx, and this is from 0 to pi. This is further equal to pi square divided by 2 minus pi by 2. Integral of sec square x with respect to x is tan x, minus integral of tan x into sec x with respect to x is sec x, and this is from 0 to pi. So this is equal to pi square divided by 2 minus pi by 2. First replacing x by pi, we have tan pi minus sec pi, minus of tan 0 minus sec 0. So this is equal to pi square divided by 2 minus pi by 2. Tan pi is 0, sec pi is minus 1, minus of tan 0 is 0, then we have minus of sec 0, that is 1. So we have minus 1. So this is equal to pi square divided by 2 minus pi. Therefore, I is equal to pi square divided by 2 minus pi, or we can say that integral of x tan x divided by sec x plus tan x into dx from 0 to pi is equal to pi square divided by 2 minus pi. This completes the solution.